So this video is really just an extension of the one in which I showed you how to add these things graphically. So this one I'm not going to go through all of the setup and the discussion about equilibrium and so forth. Let me just show you how to add these things graphically. So the way that we did this, we said 400 grams at 35 degrees. I'm going to do the exact same thing as I had before, but I'm just going to do a rough sketch here. I'm not going to do this using using the rulers and protractors. So here's my ring, there's my center. I'm just going to draw a rough sketch, and so we used blue for this one. We said something like 400 grams, and we said that this angle was 35 degrees. And then I had another one up here that was, again, this is all just rough. This was 700 grams at 160 degrees. If I'm going to do this via components and I want to find this resultant, I'm just going to try to create a triangle out of this using the x and y components of my two original vectors. So I'm really going to look for this component here and this component here, and then I'm going to also consider this component here and this component there. Now the idea behind this is that my resultant force is really going to have this component and this component, and you can see by looking at that that this component here is really the sum of all of the x components of my two vectors. So it's really going to be, let's see, d sub x from the first vector plus d sub x from the second vector. Notice that the d sub x in the second vector is negative. So let's go ahead and determine those values here. I'm going to do that with a little table up here. Okay, so let's see. I'm going to call this d sub 1. And I'm going to call this, this is the x portion, this is the y portion. So d sub 1, let's see, that would be, for that, that's going to be 400 multiplied by the cosine of 35. And that value is about 328 grams. The y component would be 400 times the sine of 35, which would be about 229 grams. Okay, so that would be the two components. That'd be 328 and 229. Now let's do the d sub 2. So d sub 2 here, let's make this be blue here. So d sub 2 is going to have a negative x component. So let's see, that would be 700 times the cosine of 160. But I'm going to make that be, well, let's just use 700 cosine 160. It should turn out to be negative. 700 times the cosine of 160. Sure enough, I get a negative 658. Okay, and then the y component would be 700 times the sine of 160, and that would be about 239 grams. And the cool thing about using my reference angle always relative to the x axis is that I can always just use cosine for the x and sine for the y. Now I can just add up the 328 and the negative 658. So 658 minus 328 means that my x component for d sub the resultant would be a negative 330 grams. So that would be this length here. I'm just going to put that in as the magnitude. That'd be 330 grams. And for the y component, add those up, 229 plus 239. That's 468 grams, and that would be this value. Right? So that whole thing would be 468. Well, the cool thing about that is to find the resultant. D sub r would be, the magnitude would be the square root of those things squared. And so when I put in 330 squared and 468 squared, and take the square root, I get about 572 grams, so about 570. And when I take the when I find the angle, I'm going to find that angle here. So theta can be found as the inverse tangent of 468 over 330, and that value would be that angle is about 55 degrees. And so if that's 55, the angle relative from x, that one would be 180 minus that. So 180 minus 55 would be about 125 degrees. And so these numbers actually are matched pretty close. We found that the resultant here would be the weight of 570 grams at an angle of 125 degrees. And again, you remember your equivalent, if you watch the other one, would be 570 grams at 180 plus 125, which would be 305 degrees. So a little bit more mathematical, a little bit faster to get through it, also much more accurately done.